Hi guys, I'm Tiffany from Steps Academy, Hong Kong's Math and Science Center, and today's video I'll be talking about organic chemistry. So let me introduce myself really quickly before we started. I am currently an IGCSE student and I'm studying international school in Hong Kong, and my predicted grade for chemistry is a 9, so that might give you a slight confidence in what I'm gonna teach you guys, and hopefully you trust me and you know that I know what I'm talking about. So my example is Edexcel. So if you're doing a different example, that might like change slightly in what we're teaching, but I don't think there'll be a big difference. Organic chemistry split into two parts, paper 1 and 2 stuff. Today I will be teaching you paper 1 first, because if you don't get paper 1, you wouldn't get paper 2. So yes, in front of you, you can see I wrote down the spec point that is for my exam board. So that's, I feel like referring to the specification is really important, because the spec literally tell you what you need to know for that exam. And if you master every single spec point, you will master the exam. So yeah, okay, let's get started. Okay, so the first point is 4.1, know that a hydrocarbon is a compound of hydrogen and carbon only. That is a really straightforward spec point. It literally tells you what you need to know. So it literally tells you what you need to know for this point, and basically an exam question for this spec point might be, what is a hydrocarbon? Usually will take you 2 marks to do this question, because you need to write 2 things to get that point. Everyone know this. Everyone know the first point, a compound of hydrogen and carbon atoms. That's like, you got to know this. But the second point is what everyone will miss. And most of the people miss this mark because of this word, only. You have to remember to say only no matter what, because only is giving you the second point. So many people thinking that, oh, compound probably give you 1 point, carbon and hydrogen atom give you the second point. Nope, let me tell you, nope. Only will give you the second point. So you gotta remember to write only. Like, I used to not know that until that my teacher literally like brainwashed us to write only. So that's why now I remember to write only, and I hope that I could brainwash you to remember to write only. Okay, so let's move on. Second point is 4.2, understand how to represent organic molecules using empirical formula, molecular formula, general formula, structural formula, and display formula. These are some stuff that is just more of a memorizing than understanding. You just gotta remember the definition. You don't have to remember word by word, because they won't be like ask you what's the definition of empirical formula. An exam question would be show the display formula for butane. That's an example of a question that will ask you in an exam. It could vary to 2 to 3 marks, but it won't be more than 3, because it's a pretty straightforward question. So you would need to know how to calculate empirical and molecular formula. It's just not in this topic. That will be in the mass most topic. So you don't need to know how to calculate in this topic. So yeah, I'll just go over and give you guys an example for each of the vocabulary you need to know. So okay. Empirical formula is the simplest whole number ratio of atom in a molecule. For example, CH3, it would be an example. I will use purple pen to do my example so that you guys know. Oh my god, that was not great. Okay. Why is it like, okay. Anyway, I'll use red. Okay. So CH3 is just an example of an empirical formula. And it's like the simplest whole number ratio. So molecule formula is similar to empirical formula, instead it's the total number of each atom in a molecule. Like for example, C2H6. Any alkane would be counted as molecular formula. So yeah. General formula is the simplest whole number ratio of atom in a molecule. That is basically similar to empirical formula, but what's different is that general formula, you wouldn't have much number in it. Instead, you will count it as n and H2n plus 2. You probably would be like, what is going on? You would know when I'm talking about alkane and alkene later. So basically, general formula is basically what form a group in alkane and alkene. Use this formula to calculate each alkane in the group and each alkene. Like this formula will show you how to calculate butane, methane, ethane, propane, and ethene, propene, butene, pentene. You just got to know these formula to know how to measure the other ones. So you probably have no idea what I'm talking about, but I promise you will understand what I'm talking about when I teach you guys alkane and alkene. So structural formula is a condensed representation to show that the symbols for each atom in a compound. Basically, that relates to display formula, but I will just give you an example first. So this will be an example, CH3 and CH3 will be an example of structural formula. So I would actually give you guys a example for that. So I quickly pop a picture of what a display formula would be like. They always love to ask you to draw a display formula for alkane and alkene. So basically, this is alkane and alkene. This is alkane, this is ethane. So this is ethane displayed formula. And you actually, if you realize, I actually use this ethane for every single one of the example. This is ethane molecular formula. This is ethane structural formula, and this is displayed formula for ethane. So why did I say structural formula and display formula is similar? So basically, imagine having a line split here. Split in this between this here. And structural formula is basically CH3 and CH3. Can you guys see it? So the structural formula and display formula are like cousins. Like you just gotta know the display formula to know the structural formula. So that's basically that. I hope that wasn't too confusing, but if it's really confusing, I can do another video into talking about this in more detail. But for now, let's move on to the next big point. So the next big point is also another definition. You just gotta memorize it, and I'm so sorry you gotta memorize it, but it is what it is. So spec point number 3 is know what is meant by homologous series, functional group, and isomers. So, oh my god, right here. Okay. So what is a homologous series? They love asking you this question, let me tell you guys. They love doing this question. They will ask you, oh, what are some 2 features of homologous series? So let me tell you what is homologous series first. Homologous series is a series of organic compounds that has similar features. So you'll be like, oh, Tiffany, what does that mean? Basically, alkane, let's say butane and propane, they're in the same homologous series because they have the same similar features. They have the same general formula, and that's one of the features that you could say for homologous series. An exam question could probably ask you, name 2 features of homologous series. Then I would give you guys 5 things to remember, and you guys could just name 2 of them. First, I already told you guys, they have the same general formula. So if you guys are smart enough, alkane and alkene are not in the same homologous series, but ethene and propene are in the same homologous series. Methane and ethane are in the same homologous series, and you will understand much more when I talk about alkane and alkene later on. So they also have the same functional group. And if you guys don't remember what's functional group basically is what I'm gonna tell you guys next. I will tell you guys next what's functional group is a definition of functional group here. So we can move on from that first. They have similar chemical reaction. So it's like group 1 metal. They have similar chemical reaction, but they are more like they're worse and worse, and they're more reactive as you go down the group. And this is similar with alkane and alkene. So, and then they have neighbor member by CH2. You'll probably be like, what is going on? What does that mean? So, alkane, I already told you guys ethane molecular formula is C2H6. So what does that mean if it's a neighbor member by CH2? So ethane, and then is methane, ethane, propane. So propane would be, take a guess. So take a guess. What does that mean? It means that propane will be C3H8 because it's neighbor member by CH2. So you basically, you know that ethane, you know that propane is under ethane. So that means that you just add this, you just add C2H6 to CH2. I mean, that's a simple math question, right? That's a simple math calculation that everyone could do it, I'm sure. So that is what I mean by neighbor member by CH2. Every single one down the group are added CH2 from the previous one. So yeah. And then the last one is basically physical properties show gradation. If you don't like that, don't remember that one. You could just write same physical properties. Same physical properties. Not show graduation. You don't want that. A more simple one is similar or same physical properties. But if you don't remember that, do not write that. Write same. Mostly what I write is same general formula and similar chemical reaction. That will simply give you that 2 mark. Okay, let's move on. Functional group. So what is functional group? Functional group is a group of atoms. I'm sorry guys, I literally couldn't spell. So, but fun fact, if you don't know how to spell in the chemistry exam, if the examiner know what you're talking about, you can still get the mark. It isn't English, guys, it's chemistry. So you just gotta know the knowledge. Spelling doesn't really matter in an exam. So of course it would be better if you know how to spell it, but if you don't, then don't worry about it. So functional group is a group of atoms bonded in a specific arrangement that controls the property of the normal series. So what does that mean? A group of atoms bonded in a specific arrangement that control the properties. So that's basically mean that, okay, functional group means that alkane, alkene, alcohol are a functional group. So basically alkane, anything inside alkane is in the same functional group. Anything inside alkene are in the same functional group. But you couldn't say alkane and alkene are in the same functional group because they aren't. But they are one functional group. If that makes sense. I hope that makes sense. So functional group mean that alkane, alkene, alcohol are functional groups. Anything in alkane are in the same functional group. Anything in the anything in alkene are in the same functional group. Anything in alcohol are in the same functional group. We won't be talking about alcohol today, but alkane, alkene. So you know, as what I list in example of homologous series, like ethane, butane are in the same functional group. If that makes sense. It's basically similar to homologous series, but you just got to. So isomers is a compound that have the same molecular formula but different structure and display formula. So that I will have to give you guys an example. Okay, as you see in this picture, butane's molecular formula is C4H10, but could you see that the way that they draw it is different? And this is something that I'm gonna continue to talk about later on. This is something that there are some people just get it instantly. There are some people like me. I used to like struggle a lot when I was doing this. And it's basically that you drew it differently. And there's different way to draw it. You could put CH3 up and you could put CH3 down. It's similar. But there are questions telling you to draw isomers for butane, and that would give you 4 marks. I know it's a lot, but mostly they would tell you to draw 2, so that's why like it's been pretty hard to explain. And there will be spec point later on to explain that. If there isn't like a spec point to explain that, I'm gonna do just one video on talking about how to do the isomers, because that's one thing that I struggle so much. So for now, I'll give you guys this example, and hopefully if you guys understand, then that's great. If you guys don't understand, don't worry, I will make another video on talking about how to do the isomers in alkane, alkene. So for now, let's move on first. So 4.4, understand how to name compound relevant to the specification using the rules of that. That is kind of useless. All you need to know is this. So the name. So me, eth, pro, but, pen, and hex. So then you would just basically is number of carbon atoms, and this is of course 1, and then is 2, and then is 3, and then is 4, and then is 5. You know, as I said, from that you could probably figure out that hex is 6. So what does that mean? What the hell does that mean? So this mean by if you writing alkane and alkene, let's say that you given a C2H4, let's say that, and you have no idea what does that mean. And let me tell you, C2H4 is basically ethene. And ethene, you can see it starts with 2 and it's C2H4. So there are 2 carbon atoms in ethene, and that is why it's called ethene. And you probably wonder why it's not called ethane, but I will tell you guys later on why it's not called ethane when it's C2H4. But when it's C2H6, then it's ethane. So for now, you just got to remember that. But how I remember before is just kind of remember MEPBPH. So I think I kind of remember in a way that are like really weird, but I kind of remember when I remember ethane and alkane and alkene group. So you probably will understand it better if you learn alkane and alkene group, then you wouldn't know and remember this. Okay, let me continue. So 4.5. 4.5 is understand how to write a possible structure and display formula of an organic chemistry molecule given its molecular formula. So this is what I am basically talking about with you guys. Display formula is basically you draw it. Display formula. You drew it like this. And structural formula is this. So let me just show you an example of ethene because there are double bond, and I was talking about single bond before, and I didn't talk about double bonds, so that is why I will show you what it's like. So ethene structure formula is CH2 CH2. And the reason why there is a double bond is just because ethene has double bond, and that's one of their really interesting feature is that ethene have double bond and ethane doesn't have. And you will understand it so much better, trust me, when I talk about alkane and alkene later on. But the display formula for ethene will be like, okay, so I found a picture of ethene display formula is basically where I circle. So remember that I told you guys that structural formula and display formula, they're basically cousins. If you know their display formula, you probably know their structural formula already. So as again you do the middle line, remember the middle line, you split them into half. And then the double bond, you don't split it, like it's not like like ionic bonding. If it's like, if you have more heat, you break it into like 1 and 1. It's not like that for alkene. You just gotta split it, and then you can see CH2, so you write CH2 double bond and then CH2. So that's basically the structural formula for ethene, and this is how you drew it. So yeah, okay, now we will move on to probably also one of the hardest. You just gotta remember the step 1 for this topic. So basically 4.6 is understand classify reaction of organic compound as substitution, addition, and combustion. I think it's addition. I have no idea, right? I write addiction, but sure. So let's talk about substitution first. So these are something that you just gotta remember is like step, is of course you gotta understand it first, but okay, let me tell you guys what substitution mean. So substitution is when a reaction where one atom is swapped with another atom. So that's basically the definition of what that means. And this is really important. This step is really, really interesting because it requires UV light for it to happen. So I'm gonna highlight this in yellow highlighter so that you guys remember that it requires UV light to happen. And one of the most famous example for substitution is methane react with bromine. And I could tell you from my experience, that substitution will not only, but mostly it will happen only in alkane. You couldn't see substitution happening in alkene because it just doesn't work. And one of the most famous example is methane react with bromine. And that's really one of the most famous example of substitution. And an example would probably they will always ask you, oh, what does it require to have this blah 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 whatever. They will probably ask you what you would need to require in this substitution. Then you will have to say, oh, it requires UV light, and that's probably 2 mark, I would say. And they probably will ask you how to write the chemical formula or word equation for this reaction. And this is what I'm going to show you. It's basically methane plus bromine gives you bromoethane plus hydrogen bromide. And also write the word equation is CH4 plus Br2. If you don't get why it's Br2, it's okay. You got to learn this when you're in when you learn group 7, which I probably will teach you guys by then. And it's Br plus HBr. Okay, so you probably will understand why it's called substitution now, because could you see it substitute H to Br instead, and the H just left behind here? Can you see? So this is why it's called substitution. And let me tell you, all of these are catalytic cracking. So all of these is catalytic cracking. And if you guys didn't learn catalytic cracking, catalyst in biology basically is an enzyme, and you would need enzyme for these. So that's why there is like a specific temperature you would have to follow. Is basically 600 and to 700 degree. And they would always love to ask you an enzyme for this. And they probably in the spec they would tell you to do silica or alumina. I don't like that. There's one that you always get it right. It's Al2O3. That is basically aluminium oxide. Al2O3. You just gotta remember this as the enzyme, then you will be fine. Of course, there are different examples as well, like silica or... So there's basically silica or silicon oxide. But I'm telling you, the easiest one to remember is definitely Al2O3. So if I were you, I would just remember Cl2O3. And it's 600 to 700 degree. And they will definitely ask you, they'd love to ask you this question in a chemistry test. They would be like, oh, what is the 2 condition you would need for catalytic hydration? Or no, not catalytic hydration. That is another thing that you gotta learn. in alcohol, that topic, catalytic cracking, then you'll be like, oh, it would need 600 to 700 degree, and it would need an enzyme like Al2O3, and you just gotta write Al2O3, and you don't have to write, oh, Al2O3 is an enzyme, because Al2O3, they will know what you're talking about. So that is really, really important when it comes to this, these reaction. The next reaction I will teach you guys is addition reaction. And of course, substitution mostly happen with alkane, so you can guess it, you guess it right. Addition helping with alkene. And that probably didn't, come as a surprise. So addition is reaction in which one molecule combines with another to form a large molecule with no other product. And okay, and here, let me tell you, it only happened in alkene, okay? It wouldn't happen in alkane because that just doesn't work like substitution. And a really, really famous example of addition reaction is that ethene plus bromine give you dibromine ethane. So let me also tell you guys the behind the message of this reaction. So as I told you, remember alkene has double bond. And double bond in this addition reaction is to break each carbon atom to form a covalent bond with another atom. So addition is the only one that could have this power to break the double bond into single bond. And you guys would know what I meant when I talk about the example now, which is ethane react with bromine. So ethane react with bromine. I will give you guys the question. Ethene plus bromine give you dibromoethane, and let's see, 2H4. And guys, remember you have to capitalize the C and the H. And don't ask me why, you just gotta know it. It's this funny funny thing in this chemistry, you just got to know it. And yeah. And also guys, I am writing this as like C2H4 right now, but in a question, in a test, you have to write the number as the bottom right of the letter. It's basically like to the power of, but instead to the power of is at the top, but for this you write it in the bottom instead. You probably have no idea what I'm talking about, so I'm gonna give you guys an example. So if you guys could see my camera, you could see that CH3Br, you write the number down and you don't write the number as like next to the letter, if that makes sense. So that's something that you gotta remember. And ethene plus bromine give you dibromine-ethane. So ethene plus bromine give you ethane. So it broke the double bond into an alkane instead. So as you see, it didn't tell you substitution because it actually added bromide instead of sub into the H, if that makes sense. That's why it's called addition, because it added a bromide into this product and not substitute the H4 into bromine instead. So that's why this can only happen in alkene, because only alkene have double bond, whereas alkane only have single bonds. So yeah, and And this is what you gotta know, and this is one of the example of addition reaction. So I've been talking so much with only could happen in alkane and alkene. The next one that you gotta learn is combustion. And combustion could happen in alkane and alkene. It doesn't matter. It could happen with alkane and alkene. And there are two different combustions that could happen. It's basically reaction in which one molecule combine with another to form a larger molecule with no other product. You don't have to know the definition. They won't be like, oh, can you tell me the definition of combustion, or can you tell me the definition of substitution, or can you tell me the definition of addition? They wouldn't ask you that. They will ask you the example though, so you gotta remember. That's why I used a red pen to make sure you guys remember the example, because it is really important. So we are going to learn complete combustion first. You guys might have come across this when you guys learn gases, with sulfur dioxide, in topic 7. I'm not sure if my topic 7 is similar to your topic 7, but when you guys learn gases and carbon dioxide and carbon monoxide, you would have come across complete combustion and incomplete combustion. So, yeah. So complete combustion is basically there is unlimited supply of oxygen. One of the example is definitely CH4 plus 2O2. And you guys remember have to balance the equation, because if you don't balance the equation, you would not get that mark, guys. So 2H. So CH4 give you 2O2, give CO2 plus 2H2O. And that is one of the really famous example, and it's alkene. Burn when heated in air of oxygen. So this is basically alkene burn when alkene burn when heated in air of oxygen, and this is one of the famous example of complete combustion, and this is what is happening in this chemical equation. And it will give off carbon dioxide, guys. It will give off carbon dioxide. And you will see the difference when I talk about incomplete combustion now. Incomplete combustion, of course, that's basically mean there is limited supply of oxygen. And this is CH4 plus 1/2O2 will give you, guys, CO plus 2H2O. Or you could write 4H2O give you 2O2. That is the same thing. And the reason why I said look at the difference is because this give you CO, guys, and this give you CO2, guys. So you gotta remember that. They won't be like, oh, when does it happen in complete combustion? When do you know it's complete combustion? When do you know it's incomplete combustion? They wouldn't ask you that in an exam question, but in an exam they will probably ask you, oh, what does it mean? Can you give an example of complete combustion, can you write me a chemical formula, or can you write me a chemical formula for incomplete combustion? Similar that. And they love to ask you the effect of carbon monoxide. So if you guys don't know, CO is basically carbon monoxide, and carbon monoxide is poisonous, guys. Okay, you will die from like smelling it. So but that is another point that I would be talking about later on in 4.13, where I explain why carbon monoxide is poisonous. So yeah, so this is basically the introduction of what you need to know for organic chemistry, and I would be talking about crude oil, alkane, and alkene later on in this video, because I think that this video is already way too long for you to get started for crude oil and alkene, because it's a lot in one video, and I just feel like you just got to remember some of the definition for this introduction first, and you got to know these reaction, let me tell you guys, it's really important. They love asking you this question. And yeah, so I will be talking about crude oil, alkene and alkene, and additional polymer later on in the video, and I'll see you guys next time.